Well, we did a practice test for Math 1108 on Chapter 1 already, but I thought another one might be very useful. So we're going to take a look today at Form B. Again, any test, this is 20 questions, will be a sampling of what you've worked on in your practice and quiz me's, and hopefully have the background through practice and mastery to tackle many different kinds of problems. And we see these, some will be similar and some will be different. All right, let's take a look at this first one. They're asking you to identify the property that's illustrated. And what do you see here? Well, there's an equal sign, and it's 7 plus 1 and 1 plus 7. In a sense, this could have been considered A plus B equals B plus A. And you may recall this is the commutative property. In this example, they're just asking you to convert from interval notation to the graph. So if you were to make a graph and do this one yourself, which is what I suggest you do, here's your number line. The number you're interested in is 2. And what is this showing? Well, because of the bracket here, it indicates that 2 is included in the set, so we put a bracket there. And this is going toward positive infinity, which is out there. So this one is also letter D. Now, for all of these examples, I would expect that you pause the tape before I give the answer or work it for you, so you can see if you knew how to do it, and that would be the challenge. So as we look at example 3 here, we're wondering, what are they asking us? Well, they give us this equation down here, which is in its absolute form. So what do you do with an equation in its absolute form? And I'll show you. So the skill you need to bring into the system is that when you have absolute value like this, you write it out without the absolute signs. Then you write the word or, write the left side again without absolute value signs, reverse the inequality sign, and change the sign of what is on the right. So then you solve each one of these, and you get, for the first one, 35,200, or the second, 32,800. Now, you're looking for years where your bar graphs are between this. So I would suggest you go to your lines here, and you're going to guesstimate 35,200. So 35,200 is right about there. And 32,800 is right about there. And then you can sketch a line in, like so, and now you pick out your answers. Well, this one is in that area, this one is in that area, and this one is in that area. And then you match it up, and it happens to be letter A. Now, again, this one problem took a lot of time. You had to know how to deal with absolute value inequalities, the technique to solve them, and then the strategy to put your values on the graph and pick out your answers. Now, in these next few, they're asking us to take a look at what skill we're going to need to solve this. Well, here we're asked to multiply terms whose base are the same, and the exponents could be the same or different. But the key is the bases are the same. So the rule is, when the bases are the same, we just add the exponents. Now they do have some other trick answers here. You have to be careful of that. The rule is a to the n times a to the m equals a to the n plus m. That is, you just add the exponents. The bases stay the same. Now in number 5, they give us a rather tedious kind of expression here, where they want you to think about it. Now they're saying that in the year X, where X is 3, corresponds to 2003. X is 4, corresponds to 2004, and so on. So what will X be in 2007? X will be 7. So here it's a matter of putting in your calculator the value X as 7 to the third power. Here our X is 7 to the second power. Here our X is just 7. And then carefully putting that in, and you end up with actually letter A. But part of it was to understand what are they asking and what would your value of X be. Following the examples they give, we get X is 7, and then we carefully substitute, and again, you're going to use your calculator. Now for number 6, they're asking us to factor out the greatest common factor. So as we look at this, remember the first term has a 1. So since this is a 1, there is no common numerical factor that you can factor out. Then the next thing is in terms of letters. Well, here this is y to the 8th. There's a y to the 1st here, y to the 3rd, y to the 8th. So the only value of y that we can factor out of each one is y to the 1st. Now since there's no w here, we can't factor out a w from anything else. So the only one that looks like an answer here is letter C. Again, the strategy, you look at the numbers, what's the common factor? You look at the letters, again, from each term. Now, while we're on this, we might ask, what is the degree of this expression? Well, we find the degree by looking at the greatest number of exponents on the variables. Here it would be 8. Here this is 5. Here this is 11, and here this is 12. So the degree of this expression, by definition, is the largest degree of any one term, and that happens to be 12. Now, they're not asking that here. It's just that since we were here, we did a little review. Now, in example 7, what we see there is a cube minus, and is this a perfect cube? Yes. So in a sense, we could look at that as x to the third minus 7 to the third. So this is the difference of perfect cubes. Now, hopefully in your lesson, you developed a little procedure for factoring the difference of perfect cubes. And that is to put a parenthesis for 2 terms, a parenthesis for 3 terms. Now the recipe is whatever the sign is, that's what you put there, which is negative. And then the middle term in the 3-term parenthesis will be the opposite sign of that, which will be a plus. Now you take the cube root of that first term, which is x, the cube root of this, which is just going to be 7. Then you square this term, which gives you x squared. Multiply these two together, which is 7x. And you might say, wait a minute, that's the wrong sign. Well, what we had said earlier, opposite sign prevails. And we're kind of using that technique, but not the sign. And then finally square the last term. And when we match it up, it matches up to letter B. Now, if you were to multiply this by this, you would get that. But this is a special technique for factoring the difference of perfect cubes. Now, if that sign were a plus, everything would be the same except this sign would be positive, this sign would be negative. Again, this is a little technique that if you mastered it, very good. All right, perform the indicated operation, write the answer in lowest terms. So here, they're giving us a division. So the rule for this is we need to factor this. Factor this. But now, since it's division, we have to change it to multiplication and take the reciprocal of this. So this one will be written on the bottom, and this will be factored up here. So to save time, let me factor it. Okay, to give a little review of this is a perfect square trinomial that will factor into its binomial squared. So I got a 6 and a 6. Both of these are going to be plus. And when I FOIL it, it gets to this. Now, again, we're looking for factors of 54 that add up to 15. Well, a 9 and a 6. And these will also both be plus. And when I FOIL it, it checks out. Now remember, this one I put down at the bottom. I'm factoring out a z, and I get z plus 6. Now this one's a little tricky because there's a negative sign there. So we want factors of 18 that have a difference of 7. And that would be a 2 and a 9. Now our middle term here is positive, so our 9 will be positive, and our 2 will be negative. Now what we do is look over and see where the 1s are. Well, z plus 6 over z plus 6 is a 1. Z plus 6 over this z plus 6 is a 1. Z plus 9 over z plus 9 is a 1. So I'm left with z minus 2 over z, which I see right there. And this is the work to support your answer. As I recall, we don't do complex fractions, but I will work it out for you to show you how the answer is attained. So the technique to solve is you look at your common denominators for both what's in the numerator and the denominator. So it's an x plus 5, an x plus 1, and also this x minus 1. So you write that on the top, write that at the bottom, and now you're going to multiply this term by this. Notice that this then cancels out. So you FOIL this, multiply it by 3, and you're going to get, a really big answer here. Now, then you will multiply this term by this, where in this case the x plus 1 cancels out, and you FOIL this, and then multiply everything by a negative 2, and then combine like terms. And the same thing down here. Now what I would do is I'd put that negative up there and make this a positive. Much easier to handle. So again, the x minus 1s would cancel out. You'd FOIL this and just multiply it by 1. So it's just the trinomial. This would then cancel out with this one. FOIL these two, which are conjugates, by the way. So this would be x squared minus 1 times each of these by a negative 3. Put that there. Combine like terms. And for those of you who ventured this, the answer ends up being B. Again, we don't do that, I believe, in our curriculum, so that was a pretty tedious one. Now, this next one, it just depends how it's written. It's y to the 8/10 divided by y to the 3/10. And the rule is you bring your exponent from the denominator up to the numerator where you subtract it. The sign changes. So this becomes y to the 5/10, which equals y to the 1/2 power, which is letter B. Again, I don't like the way they write the fractions here, but I guess that's what they had to do. Now, write the rational exponent expression as an equivalent radical expression. So it's going to be, since this is negative, we're going to move it down to the denominator as, in parentheses, 7x raised to the 1/7 power. It's now positive. Well, in converting it to its radical form, we said we take the denominator of our fraction, our fractional exponent, that becomes the index number, write the radical sign, and we put in the base, which becomes our radicand. And since that's to the first, we don't have to write it. So that looks like letter C. In number 12, they're giving you this radical equation, telling you that this is the cost, and it's this. So to solve for the letter N, we would substitute this, We subtract 200 from both sides. We then try to isolate our radical, which we want to do, by dividing both sides by 400. We get the third root of n equals 8. Now, to get rid of a radical sign, the rule is whatever the index number is, we raise that to that power. If we do it to that side, though, we must do it to this side. So this just gives us the letter n then, and that is 512. And that is letter D. So again, knowing how to deal with radical equations is one of the skills. Now here we have a rational equation in which there are fractions. And the rule is, if you want to start it before I do, multiply each term, this is one term, this is one term, and this is one term, by your least common denominator, which are these two, which is x squared minus 4. These are conjugates. So again, we said there were 3 terms, and these were conjugates. So I've listed the conjugates, which is my lowest common denominator, and I'm multiplying each term by that. Now I could have put it out there once and used another technique, but I like this technique. So when I multiply this by this, these cancel out. And I end up with 4x plus 8. So I'm just multiplying what's left. 4x plus 8 equals, now I did multiply these conjugates to get the difference of perfect squares. This then equals x squared minus 4, because it's just times 1. And then here, this will cancel out. And I get 6x minus 12. So a much easier equation to work with. Now I group like terms. I get 4x plus 8 equals x squared plus 6x. And then here this is a negative 16. Now I have a quadratic equation, so I need to put it in standard form. So I'm going to subtract 4x from both sides. And that gives me 2x. I'm going to subtract 8 from both sides. That gives me a negative 24. That equals 0. Now I have a quadratic equation. I want to solve it by factoring. X, 6, 4. My middle term is plus, so the 6 is plus, and this is a negative. Now I equate each of my factors to 0, and here this is x equals 4, or x equals a negative 6. Now when I put them back in this equation, they should check out. And I see it looks like letter C. Here's my answer. Now, if one of the answers happened to come out as a 2 here, then that would not be an answer, because you can't have a denominator that is 0. So if x were 2, 2 minus 2 is 0. Or if it was a plus 2, negative 2, I should say. That was a plus 2, negative 2. But here our answers of 4 and negative 6 work out just fine. Okay. We'll give you a moment to look at this. Absolute value. So again, you're just going to write two equations. One without the absolute sign equals this. One without the absolute sign but equals a -4. And then solve it. So a technique would be, again, just write it without the absolute signs, equals 4 or equals a -4. But you could put 4 over 1, 4 over 1, and you can just cross multiply. So this would be 3 equals 4y minus 24. Just cross multiply. And here this is 3 equals a -4y plus 24. And then you solve each one. Here we add 24 to both sides, or just transpose it. Get 27/4 after we divide by 4. Here I'm transposing the -4y, make it a positive 4y on this side, subtract 3, get 21. Our answer is B. Okay. Okay, here they're saying the sign is in the shape of an isosceles triangle. So I would suggest you make an isosceles triangle. That is, two sides are the same size, same length. One side is 12 inches shorter than each of the equal sides. So this will be x, this will be x, and this side is x minus 12. So find the length of the equal sides if the perimeter is this. So you can pause, or you can write the equation. X plus x plus x minus 12 equals 57. So we could group like terms, subtract or add 12 to both sides. Now divide both sides by 3. We get 23. And that would be the equal sides is what they want. Okay, we're going to factor to solve this next equation. So look what we have there and see what we do. I don't know if you recognize this, but this is a perfect square and this is a perfect square. So we're going to factor so that we end up with the conjugates. So this will be 3k plus 4, 3k minus 4, equal each of these factors to 0. So this will be a -4/3, and this one will be a +4/3, and a -4/3 +4/3 is letter C. Now for this next one, they want us to use the quadratic formula to solve the equation. The key, you may remember, is to put it in standard form. 4n squared plus 12n plus 3 equals 0. So you can identify your A value, your B value, and your C value. And let's see which one you get. We'll take it in steps. Again, there's your quadratic formula. B is 12, so negative B is a -12. B squared is 144, minus 4. A is 4. C is 3. And 2a for the denominator makes it an 8. So let's group like terms and see what we have. So we took care of what's under the radical sign. By the way, that is the discriminant. And it turned out to be 96. but 96 is 16 times 6. So I took the square root of 16, and that's where I got the 4. And then under the radical sign is 6. So this is where I am. So what I can do now, do a little canceling. 4 will go into there 3 times. That'll be a 2. 4 goes into there once, that I don't write, and this is a 2. So I end up with this as an answer. Now you could write it all over 2, the way they've done it, or you could write it separately. That should be completely satisfactory. Okay, let's go on, because we're going to use this discriminant, what is under the radical sign, to determine the number and kinds of solutions we're going to get. Now, since we ended up with 2 real irrational numbers, we could see it when we got this. That's what we're going to do there. So for this one, we're just putting what we have under the radical sign, which is called the discriminant. So our b is 6, so that's going to be 36, minus 4, a is 1, and c is 9. So interestingly, this comes out to be 36 minus 36, which is going to be 0. So when we have the square root of 0, that's just nothing, is 0. Whatever we have, we only get one answer. So that is letter A. Now, if this turned out to be negative under the radical sign, then there would be no real solution. And if this turned out to be positive, other than not a 0, but a positive number, then there would be 2 solutions, because it's plus or minus what is there. Okay, that was a good review. Now, for number 19, again, this is not in standard form, so we have to put it in standard form. 2c squared plus 4c minus 1 equals 0. Now we can identify our a value, our b value, and our c value. You put that into the quadratic formula, and then they actually want you to approximate to 2 decimal points. And when you do that, it comes out to letter B. All right, let's work on this last one. I'll write it up here. Now it's A equals pi r squared, and you want to solve it for r. Okay, well, the first thing you want to do is isolate the r squared. So we're going to divide everything by pi. So now the pi's cancel out, and we get r squared, I could write it this way, equals a over pi. Now, how do we get r by itself? Well, we take the square root of this side, and then plus or minus the square root of that side. And that leads us to letter A. So, not too bad. All right, it took me 40 minutes, I believe, to do the other tests. This one we cut down on things, and again, you want to use your strategies from practice and Quizme's, your homework logs, your knowledge, your textbook reading, whatever, to find out what do they want us to know for Chapter 1, and then they will test you. Good luck.